Hello, in this video we're going to talk about how to graph a numerical data. So when it comes to numerical data, to describe it, we will use the shape, the center, how they spread, and the unusual features such as outliers. When it comes to the shape, we'll be able to see the trend. Are they skewed or are they bell curve? Are they centralized? The center, which tells us the expected value, and how well they spread, which is the variance or standard deviation, things like that. So here is a set of 15 exam score for a fractional statistic class. So we got 31, 62, 65 here. Now we want to draw a dot plot for the data. So what is dot plot? So dot plot is a way for you to visualize these data, how they spread out. So the first step is you want to draw a line that long enough to hold all of your data. The second step is we're going to label the plot, and scale should we label them. And then we should scale the line, and the scale should be consistent. What does it mean to be consistent? That means you want the same width to represent the same unit. Such as our data is from 31 to 100. So maybe we can start with 30. And then in here it's going to be 40, 50, 60, 70, 80, 90, 100, 110, and 120. Of course, the total length can be just from 13 to 100. And then the third step is you want to draw the data out on the plot. So which means we have 31. So that means our first data is going to draw in here. And 62 is going to be here. Then we have 65, 70, 76, 81, 82, 87, 88, 89, 94, 95, 98, 100. So here is our dot plot. And the last step is understand how to read the data. Okay, so right now we have 15 data. It's very easy for us to just label every dot on these dot plots. But what if we have a large data set? If we have 1,500 data set, maybe it's not as easy as to just draw the data plot like that. You might end up have 1,500 dots. So in another word, this one is good for small data. Good for small data set. Now let me introduce you histogram. So histogram is good for large data set. So the idea of Histogram is to group out our data and set the bin width so that your data can be sent in one bin. So to group our data. Okay, so for example, first we want to group it. How do you want to group it? So we have a data from 13 to 10. You can group it from every fifth, such as the group can be from 13 to 13.5, and then 13.6 to 40. You can group it in this way, but for me, I would prefer to group it in from 13 to 39. Then 40 to 49, right? And go on until we hit 19 to 99, and then 100 to 110. So the way we started, we should start it with 13, 40, 50, 60, 70, 80, 90, 100, and 110. So you might notice that I didn't start with the origin, the beginning point with 13. In fact, this point is the origin. So the origin is always 0. Now then we have a problem. Each bin width is different, right? Because for here is 10, right? The width is 10, but we know that the origin is 0. From the origin to the first bin width, this is 13. So this is unequal, and we don't want that. So what we're going to do if something like that happens, we will have a 9 of bracket. So this one is called 9 of bracket. That means, okay, this one is okay to not have the same length with the other bin. All right, so now let's group our data. Let's count it and see how many, oops. So let's see, how many data is from 13 to 14? Oops. So we have from 13, we only have one data, so we just need to connect one. So here we already set up the y value, we already set up the y-axis. You might already notice that, hey, the y-axis is going to be the x-axis. The x-axis is going to be the data value. And for our y-axis, it's going to be the counts of the group or the frequencies. So in here, we only have one data in the group from 13 to 40. So our count in here should be 1. Okay, so let me enable our y-axis. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our next group is 62 and 65. They belong to the group from 60 to 69. So that means from the bin 60 to 69, we have 2 data. So it's going to be in here. And then the next one is going to be from 70 to 79. So from 17 up to 79, we also have 2 data. Now the next one is from 17 to 80. We have 1, 2, 3, 4, 5, 6. 6 data. So that means I'm going to, oh, sorry, I forgot. The 17 to 76. We have a 2 data set in here. From 80 to 19, we have 6. And then from 19 to 100, we have a 19.4, 19.5, 98. So totally 3 data. So now we have a 100. So 100, should 100 be in these bins, which is from 19 to 100, or 100 to 110? In fact, we have a rule, it's called right-hand rule. Let me erase this part. So, right-hand rule stated data on the edge of the bin goes to the right hand. So, for example, 100 is on the edge. So that means it goes to the right side. So here, so 100 should fit in that 100 to 110 category. Okay, so basically each width, in here the width should be including 100, but not including 110. So for the 19 to 100, it's more like including 19s, but not including 100. So here's the explanation for each bin. So that's it for today's lesson. I'll see you in next videos.